good afternoon.
Yes.
Welcome back. It's really cold in here, so I have little gloves. Okay, let's continue with what we were talking about Friday. Friday we started on trapezoids. We didn't get to the kites. Okay, so a reminder on the trapezoid: four-sided figure. One pair of sides are parallel. The other pair of sides are not. The parallel sides are called bases. The non-parallel sides are called legs. We can take a rope and we can tie it from midpoint to midpoint of the legs and create the midsegment. Midsegment has a cool little formula. There it is. It says midsegment is equal to half of whatever you get when you add the bases together. And you can use that to solve some problems. We left 2 examples in this section blank for the homework on the notes due tomorrow. You need to complete these 2 items with the help of your classmates. At the bottom, we threw a trapezoid party. We had the bouncer at the door checking IDs, and he had to check to see if the thing was a trapezoid to get in. Once we discovered this was indeed a trapezoid and we let him into the party, there was a VIP section and they were drinking Dr. Pepper.
No, it was fruit punch.
Fruit punch, excuse me, thank you, you're very right. Another class was doing Dr. Pepper. Y'all were fruit punch. So this trapezoid wanted to get up to the VIP section, the very important polygon part of the party, and the bouncer there had to check to see if he was an isosceles trapezoid, and this poor little guy, not able to go and drink fruit punch, he was not an isosceles trapezoid. You will need to play bouncer again for this other trapezoid that's coming in. Draw him, check his ID, state whether he's a trapezoid and can get into the party, and then check to see if he's an isosceles trapezoid so that he can get in to drink some fruit punch. Again, that will be considered part of the homework, and this will be due for you tomorrow. Okay? All right. Let's continue with our notes. We're working on the kite. So a kite is a quadrilateral with exactly 2 pairs of consecutive sides being congruent. Those are the sides next to each other, the sides that are creating a corner. So these 2 are congruent to each other, and these 2 are congruent to each other. Notice it's not the ones directly opposite each other, it's the ones that are next to each other forming a corner that are the same measure. Those are the ones that are congruent. So, unlike the parallelogram, the opposite sides of a kite are not congruent to each other, nor are they parallel to each other.
Is that not congruent?
It says not congruent, yes sir. Sorry, it zoomed out real big just so that you can read the whole thing. I'm very sorry. Bless you. Bless you. Kites have 2 theorems connected to them. The first theorem says that if we have a kite, its diagonals are perpendicular. What did perpendicular mean?
The same.
That's congruent.
Oh, no.
The plus.
The perfect plus, meaning those angles are what measure?
90.
All right, angles are 90. Okay, so we have a little right angle marker in there, and if it's not on the picture, you can add it, because this theorem says so. And this little upside down T right there means perpendicular, so you may see me write an upside down T, because I get lazy, and I don't want to write the word perpendicular. All right, the last theorem for kite says if it is a kite, then exactly 1 pair of opposite angles are congruent. And it's a specific pair, okay? It's not just any pair. Let's see which pair it is. Notice these 2 sides are congruent to each other, and these 2 sides are congruent to each other. The angles that are congruent then are these here, the ones that are formed by those non-congruent to each other sides. Those corners, those are the ones that have the same measure. Okay? Questions about these theorems? No, we're good? Okay, we've got 6 examples. I would love to get through as many of these as you all want. Because of how closely I want to zoom in so you can see my writing, I am going to redraw the figure every time. You do not have to, as the figure's over here, but you're welcome to because numbers are going to change from one problem to the other. Okay? All right, so I'm going to draw the figure. Here it is, and it's labeled H, G, K, and J. And then it has diagonals. There they are. They're so perfectly straight lines. Just pretend for me. Thank you. And this point right here is R. We've been asked to find the measure of angle JRK. JRK, we want the measure of this angle right here. How do you know?
Right.
It's a right angle. Which theorem did you look at? This first one. This one right here. You're absolutely right. We were just directing you to exactly where you got your answer. Right here, this first theorem says that they're perpendicular. Perpendicular lines form 90-degree angles, and so that measure is 90. Well done, sir. All right, time to draw the next figure. R shows up again, so I know I need to throw my diagonals in there. H, G, K, J, there's R. All right. I've been told that the measure of angle the length of side RJ, that's this one here, that is 3. And then I'm told that the length of side RK, which is right there, that measure is 10. And then we're told to find JK, which is right there. All right, what kind of shape do we have? What kind of triangle?
Right.
A right triangle, because since this is a kite, we know that those diagonals intersect at a 90-degree angle. So I'm going to draw this right triangle out here by itself where we can see it. Here is R, here is J, here is K. I was told that this length is 10, this length is 3, and this length is the one that I don't know. Since it's a right triangle, what can I do?
It's a formula, right?
Mm-hmm, it is a formula, you're absolutely right.
That
Yeah.
theorem.
Yeah, Pythagorean Theorem is what helps us solve these. Pythagorean Theorem is a squared plus b squared equals c squared. The only one that's important to get in the absolute correct position
C.
is C. It has to be this one across from the right angle. I don't care where you put the other two. Okay? All right, so we'll put A here. We'll put B here. And my question mark will go here. Are you okay if I leave it as the letter C for the question mark?
Yeah. Yes.
All right. I'm going to go ahead and solve this down. And now my hands are warm, so thank you so much for letting me borrow the gloves. All right. So that's, 9 plus 100 equals c squared. 9 plus 100 is 109. In order to get rid of the square power, I need to put the... It's a square something.
The square root.
Yeah, square root. You're going to take the square root of both sides. And so that tells me that c is equal to the square root of 109. I don't really know what that number is.
We don't solve it, yeah.
Yeah, well, we don't need to. Yeah, we're not going to right now. So that's about as far as we can go. Don't stick this in your calculator and give me a decimal, please. I would like exact number answers. The decimal points are those.
We're not going over everything, right?
Yeah, they're más o menos. We can go over all of these if you'd like, yeah. All right, did we answer the question? Did we find what we were asked to find?
No.
Okay, we were asked to find JK. JK is the same as this measure C. So,
yes.
yes, we did it. It just wasn't labeled in a way that made sense. So we'll relabel it. All right, number 9. I need to redraw the figure again. There's my kite. H, G, K, J. All right, I'm told if measure of angle GHJ is 90, GHJ, so this angle right here, that's 90. And then the measure of GKJ, GKJ, this angle right in here, that's 110. This trapezoid is very clearly drawn by our favorite map maker, not to scale. That angle is supposed to measure 110. It doesn't look like it. But you know what? Don't worry about it. We don't care what it looks like. We only care what the numbers are. That number says it's supposed to be 110. Okay, boss, it's 110, even if it doesn't look it. The next thing that we're told is we want to find the measure of angle HGK. HGK, we want this one. Now, one of our theorems says that in a kite, there's one pair of angles that are congruent to each other. Is it these pair? Is it this pair? Are these congruent to each other?
No.
No, which means it has to be these that are congruent to each other, yes? All right, I need a variable for this angle measure, please. Your favorite variable. X. Okay, so they're both X. Thinking back to section 6.1, which I know was a while ago, it was before Christmas, but it's part of this chapter, so I get to use it. Back in section 6.1, and you can go back and check the YouTube channel. I should have, hopefully, cross my fingers that I have the video up for that. We're going to use the polygon angle sum. The polygon angle sum formula said this: n minus 2 times 180 will tell me how much you get when you add up all the angles inside of a shape. That n stands for the number of sides. How many sides in our shape? 4. So I'm going to replace the n with 4, and I get 2 times 180. 2 times 180 is?
360.
360. And so 360 is what I get when I add up all of these angles.
Maybe not.
90 plus the one I don't know plus 110 plus the other one I don't know. And now I have an algebra equation that I don't have to work very hard. I can just solve it for x. Okay?
Like 80. X equals 80.
Okay. He's saying he
Maybe.
thinks it's x
Maybe.
equals 80. So we're going to go ahead and show out the work, double check it. Going to add these two together.
200. So we have 160 left.
And then I'm going to add those two together.
160 is equal to 2x.
So subtract the 200 from both sides. I have 160. Divide both sides by 2. I'm left with 80. Did I find what I was after?
Yes.
And then I'm done. Oh, but it has to say the measure of angle, right? Because I was asked for measure of angle. Yeah. Just give myself a little wall there. All right, I need to draw another kite, so I'm going to draw this kite again. And I go ahead and draw it this way. Why not? That seems like a good kite. So H is here, G is here, J is here, K is here. I'm told that the measure of HJ right here is 7. And they want me to find the measure of HG. Now, if I take a look at my kite, these two are congruent sides, yes?
Yes.
They're consecutive sides? So they're congruent. I'm done. Yeah, nice and easy, yes? Alright, this one includes an R, so that means that I need to put in those diagonals. So I'm going to go ahead and draw my kite this way. There's H, there's G, there's K, there's J. Here are my diagonals, and this one will be R. Alright, I'm told that HG is 7, and GR is 5, and I've been asked to find HR. What's the setup? Yeah, we're going to draw something off to the side, yes? Yeah. What are we going to draw off to the side? Shh, shh. What kind of shape is that I just colored in? What kind of triangle?
Right triangle.
Yes. Right triangle. So with our right triangle, what can we use? Look at number 8. Yeah, the Pythagorean Theorem. Pythagorean Theorem says a squared plus b squared equals c squared. I'm going to do this without redrawing that right triangle, showing you that you don't have to redraw it if you can see it. If you can't see it and you want to draw it off to the side, you're welcome to. Okay, remember that the only one that's important to keep in the correct position is C. The others, I don't really care. Okay, going to subtract the 25 off. 49 minus 25 is?
24.
Okay, thank you. I was sitting there starting to count in my head. To get rid of the square power, I need to take a square root. And so a is the square root of 24. Please do not put these in decimal form. I know you're very good at doing that, so I want you to get used to writing them weird like that, okay? You're going to need to be able to do that in Algebra 2. Last one. This is it. Okay, I'm going to redraw my kites, H, G, J, and K. I was told that the measure of GHJ is 52, and the measure of GKJ is 95. Once again, drawn by our favorite map maker, not to scale. We need to find HGK. We want this one. This is exactly like number 9, so I'm just going to fly through this. Because it's a kite, those two have to be congruent. By the polygon angle sum, this kite's interior angles measure 360. And then I'm going to add up all of the angles inside and set it equal to them. I'll end up with an equation that then I can solve for x. I'm going to go ahead and do that. Please double check my arithmetic, okay? Or shout out the numbers as I need to write them because it's going to take me a long time. That's a 7.
47.
Thank you. Looks like I'm going to get a decimal here. This is okay for a decimal. I heard someone say 206.5. I'm going to go ahead and just copy that answer that I heard because it sounds reasonable and I believe you. Okay. Thank you. And that is the measure of the angle that I was looking for, and so I am done.
This did not follow logic at all.
Which one?
Like where the 110 is the extra
Oh,
angle and all that.
yeah, it's not drawn to scale. And that's going to happen a lot, especially when I'm just kind of quick sketching the figure. Before I put the numbers down, I don't know what size those angles are, so I don't know how big to draw it. I'm just going to draw it. Any other general questions about these? Yeah, the kites are definitely a little less intense than the trapezoid. I agree with you. All right, so if there's no other questions, that's all I had. Thanks very much.